So, when we talk about programming, sometimes the most powerful tools are the ones that are the most flexible. And today, we're looking at a perfect example of that, the Deque. It's a really cool data structure that's basically a hybrid of two others you've probably already heard of, and that's exactly what makes it so special.
Okay, let's start with a little thought experiment. You know how a normal queue works, right? It's like a line at a coffee shop. You get in at the back, you leave from the front. Simple. But what if that line had two front doors? What if you could just as easily join or leave from either end? That one simple change is the entire key to understanding what a DQ is all about.
And the answer to that question is the DQ, which is short for a double-ended queue. And a quick tip, you usually just pronounce it deck, like a deck of cards. As the name suggests, it totally breaks the strict rules of a regular queue, giving you access to both the front and the back for adding and removing stuff.
So that's the big idea. But how does this actually work in practice? Let's walk through the four main operations that make a Deque a Deque. We're going to build one from scratch, right here.
All right, so we're starting with a totally blank slate, an empty deck queue. First, let's do something that should feel pretty familiar.
We'll use an operation called add last to put the number 10 in. So far, so good. This is behaving exactly like a standard queue.
Let's do that again with the number 20. We use add last, and it goes to the end of the line. Still, just like a normal queue, right? But now we get to see where the Deque's special powers come into play.
Check this out. This is the add first operation. Instead of going to the back like everyone else, we can just slide the number 30 right into the front of the line. That's its first superpower, something a regular queue just can't do.
But, adding elements is only half the story. A Deque's flexibility is just as amazing when we need to take elements out. Let's see that in action.
So if we call remove first, it does exactly what you'd think. It grabs the element from the very front, which in this case is that 30 we just added. Poof, it's gone. We're just left with 10 and 20.
And now for its other superpower, remove last. Instead of being stuck taking from the front, we can just pop an element right off the back. So the 20 disappears, leaving us with just 10. This total control over both ends, for both putting in and taking out, is the whole essence of the Deque.
This incredible flexibility means a deck isn't just one thing, it's kind of a chameleon. It can perfectly imitate two other fundamental data structures, just by choosing which of its powers we decide to use.
This is where the whole hybrid idea just clicks. Look, if you only ever use add last to put things in and remove first to take them out, what do you have? A perfect first in, first out queue. But if you switch your strategy and only use add last to add and remove last to remove, you've just created a last in, first out stack. It's one data structure that can be a perfect stand-in for two others. How cool is that? Okay, so it's flexible, it's a chameleon, but is this just a neat party trick? Where would you actually use this thing in the real world? Let's take a look at some problems where the damn isn't just useful, it's a lifesaver. DEQs are not just some theoretical concept. They are absolutely essential for solving all sorts of tricky problems. For instance, they're famous for how well they handle sliding window problems. Imagine you're analyzing a constant stream of data, but you only care about the last 10 things that came in. A Deque is perfect for that. It makes it incredibly efficient to add the new item to one end while you kick the oldest item out the other end. And that same efficiency is why you'll see them pop up in complex search algorithms for things like trees and graphs.
And really, this brings us right back to the core definition. It's that simple ability to insert and delete at both ends that just supercharges the whole thing. It turns a simple line into this powerful dynamic tool for problems like that sliding window we just talked about.
So, if you walk away with one single thing from all this, let it be this. The DQ is your go-to data structure when you need maximum flexibility. Whenever you're facing a problem where you'll need to efficiently add or remove items from either the beginning or the end of a sequence, the DQ should be the first thing that comes to mind. And that leaves us with one final thought. If the Deque can do everything a stack and a queue can do, and then some, why do we even have those simpler structures? When is having less flexibility actually the better choice? That's a great question to think about as you keep digging into the amazing world of data structures.